Okay, happy Sunday, Math 101 Hazleton students. Justin Bashara here, of course. Today, as promised, I will do the last section video, part 2. So we're going to look at section 6.2, part 2. Part 1 was about the properties of the real numbers. So we talked about how the real numbers as a set on operations, adding and multiplication, form what we call a field. So that means they have closure, the commutative property, associative property, an additive inverse, an identity, and a distributive property. And the inverses and identities work on both addition and multiplication. Today, in this video, we're going to talk specifically about the more concrete operations. So how do we add, subtract, multiply, divide integers specifically, but this covers all real numbers. And we're also going to look at the order of operations, which you've learned long ago, probably 6th, 7th, 8th grade. Probably that please excuse my dear Aunt Sally crap, I like to call. I call it crap because it's kind of inconclusive, and it's too bad that we weren't in class for this lecture, because I really get into this part. I like to slam that PEMDAS because it's kind of incorrect. It gives you a false sense of security, I think. But I just want to start off with just something that we touched base on last time in the previous video, which would have went back to 6.1. We want to perform operations with these sets. So for example, there's some ones that's a little more interesting. Say we want to take the rational numbers and we want to intersect that with the irrational numbers. If you remember from the diagram I drew, and that's in your lecture notes, the rational numbers and the irrational numbers have nothing in common other than that they are considered real numbers. But if we take the two sets in general and we want to intersect them, there is nothing in common. So that would be an empty set. So our rule that I kind of gave you about the bigger of the two sets or the smaller of the two sets for a union intersection will determine what it is, that's not always true, and this is an example. Say I want to take the rational numbers and union them with the irrationals. This is a very interesting set, because if we essentially add, union really means add, you learn that in probability. If we add the rational numbers and the irrational numbers together, that actually gets us the set of real numbers. So these are kind of exceptionalities that we have. Other than that, some of the other ones do work fine for us. Say, for example, we want to take the integers and union that with the rational numbers. If it's a union, we want to take the bigger of the two sets. And this is a case that works out nice. This would be the rational numbers because they are bigger than the integers. Cantor, the man that we talked about at the beginning of the course, he had much to do with telling us how we could figure this stuff out using a one-to-one correspondence. If we take the integers and we intersect that with the rationals, intersect means we want the smaller of the two, so this would be z for integers. So I just wanted to review that briefly before we got started on the new stuff. So let's take a look at some of the operations we have with real numbers. We'll start with multiplying and dividing first. The more interesting cases are when we have signed numbers like integers or other numbers. By the way, one of the things I always thought as a kid was that if a number was negative, it's always an integer, and that's not always the case. For example, negative 1.2, that is not an integer. That would be considered a rational number. So just because it has a negative doesn't mean it's an integer. Now, if we had negative 1, that would be considered an integer. So just keep that in mind. But anyway, let's talk about multiplying. And for multiplying, we just have to watch the signs, essentially. I mean, look, you have a calculator, I'm sure, at home, so you're not going to do this by hand. I give you credit if you do. But if you have a negative number and you multiply it by a positive number, you get a negative number. If you have a positive number and you multiply it by a negative, it's negative. If you have a negative times a negative, that gives you a positive number. This is always the interesting case. And if you have some time, see if you can find out why two negatives, when you multiply, it gives you a positive number. It's kind of interesting if you see it. And of course, if you have two positive numbers and you multiply them, it's going to be positive. The same thing goes for division. So if you divide a negative and a positive, you get a negative. If you divide a positive and a negative, you get a negative. If you divide two negative numbers, you get a positive. And if you divide two positive numbers, it's obviously positive. You know, for example, negative 2 times 3 is negative 6. You could also write it this way with parentheses. An interesting case is, what if we have a couple numbers being multiplied? Say we have negative 2 times negative 3 times 3. It's all multiplication. You should know what the signs are going to be before you're done. If you have an even number of negative things and you multiply, it's going to be positive. If you have an odd number of negative things, it's going to be negative at the end. So our answer is going to be positive. 2 times 3 is 6. 6 times 3 is 18, so that'd be positive 18. Another thing that we should kind of talk about is the idea of exponents, right? You guys know about exponents at this point. And we got to be careful how we handle them, because there's always miscommunication. Let's say we have, for example, 2 squared. Well, what does that physically mean? It means 2 times 2, right? So that's 4. But what happens when we have something like this? Negative 2 squared. What does that mean? Well, notice that the parentheses around the whole number negative 2. So that means the sign is going along for the ride. So that's going to be negative 2 times negative 2, which should be a positive 4. Which is different than if I have negative 2 squared written this way. You see how there's no parenthesis at all? What that means is we want the opposite of 2 times 2. So this would give us a negative 4. So parentheses are a big deal. This would be negative 4, while this would be positive 4. And you specifically have to watch out anytime you have a positive exponent. It could be either positive or negative, depending on if you have parentheses, okay? So just be a little bit careful of that. There's a nice exercise in the textbook with parentheses. For example, maybe here's an expression I have. How about the opposite of negative 2 squared, and this is raised up to the 3rd power. You want to do everything inside this bracket first. So negative 2 squared written this way is positive 4. So now you have this 4 with the minus in the front, and that's raised up to the 3rd. So what does this mean? It means negative 4 times negative 4 times negative 4. So your answer is going to be negative. You have an odd number of minus signs, and this would give you 64. So negative 64 would be your answer. So that's how exponents and multiplication kind of go hand in hand. Hopefully that's something you may remember from the past. If not, the book also talks a little bit about this to you. Now, another thing that we have to talk about is division. Division, we gotta watch out. We cannot divide by 0. So things like 2 over 0 is what we call undefined. Now, on a smartphone, if you try to do 2 divided by 0, your calculator might give you an infinity sign. So we can't do this. But however, if we do 0 divided by 2, that's fine. That would be the number 0. You know, I think there's an exercise in the textbook about this. How do you explain to a child something like 2 divided by 0? You know, think of it as if you have 2 cookies and you're dividing amongst 0 people, right? How many cookies is each person going to get? Well, you can't do it because there's no people to share it amongst, not even yourself. So that's one way that you could think of something like 2 divided by 0. This is very important because in some of our order of operations problems, we're going to see that we may get a 0 in the denominator. And if that happens very quickly, you could stop the problem. Doesn't matter what happens on the top because it's going to be undefined. So this idea leads us into the order of operations, which will be coming up soon here. But before that, I just want to briefly talk to you about adding and subtracting real numbers. And again, you have calculators. So it's nice you have a calculator, but I do want to show you again how this works. Let's say, for example, we want to add two numbers like -3 and a +2. Well, -3 plus 2 is -1. Now, concretely, what does this mean? This means that if you look at a number line, right, here's -3, -2, -1, 0, 1. What this means is you're going to start at -3 and you're going to move 2 to the right, 2 in the positive direction, 1, 2. So where do I end up? I end up at -1. What does it mean mathematically without a number line? The rule says this, and this is also in your book, so I'm not going to write this out. It's in your lecture notes. If you have a negative number and you're adding a positive number to it, essentially what you're doing is subtracting the bigger number from the smaller. So 3 is bigger than 2, so 3 minus 2 is 1. And you keep the sign of the bigger number. So the bigger number here is 3. So 3 holds a minus, so that's why your answer is going to have a minus. Let's look at another one. Say we have -20 plus 18. So what this means is we have -20 and we want to go 18 in the positive direction. The rule essentially tells us if you have a negative and a positive number, and by the way, it doesn't matter which order they're in this case, you subtract them. So 20 minus 18 would be 2, and we keep the sign of the bigger number. Well, 20 is a bigger number than 18. What kind of sign does 20 hold? It holds a minus sign, so this would be -2. So -20 plus 18 is -2. What if we did something like -18 plus 20? Well, again, we have the situation that we have -18 and we're going 20 in the positive direction. So what is that going to tell us to do logically? Subtract the 2. So 20 minus 18 is 2. And we keep the sign of the bigger number. 20 is the bigger number. It's positive, so our answer would be +2. That's how you should think of this if you didn't have a calculator. When I was in 6th and 7th grade, this stuff really messed me up, to be honest with you, because my brain wasn't thinking in this way kind of yet, I guess. Whose brain really is working that way unless you're a child prodigy in math. It was kind of hard to grasp, and there's a lot of adults, I think, that have a hard time with this. So if you struggle with it at first, it's okay, but that's how you would do this type of thing. Now, if we introduce subtraction, say we have -3 plus a -2, this would be -5. Typically, we don't write it like this. We would just say -3 minus 2. These are the same thing. But what this rule says is if we're combining two numbers together and they hold the same sign, we just add them and keep the sign. So -3 and a -2 would be a -5. Some weird things that do happen though. What if we had something like -3 minus a -2? Your book likes to do tricky stuff like this. What does this mean? Well, if you read back in section 6.1, this is what we call a double negative rule, which says if you have the opposite of a negative, like we have here, it becomes positive. So this would be -3 plus 2, which would be -1. What if we had something like 3 minus a -2? Well, 3 minus a -2, this is going to be 3 plus 2, which is 5. So again, you just have to be a little wary of the signs there, okay? So this is a good place to pause the video for a moment to go back and look at some of these things. What I'm going to go over next with you is going to be the order of operations. I'll show you why I don't like PEMDAS, and we'll kind of fill in from there and do some examples. Okay, order of operations. Now, when I was in school, I'm sure everybody else is in school, you've probably seen this thing, PEMDAS, or please excuse my dear Aunt Sally. When you study math, you learn that this is kind of garbage, but I'm going to show you why it's kind of garbage, but kind of good. When you do order of operations, you're dealing with this scheme where you have multiple operations occurring in one given problem. So the P usually stands for parentheses. This is your exponents. M is for multiplying, D is for dividing, A is for adding, and S is for subtracting. Now, why this isn't good is because, to start, this is where the big problems come in. Students think you always multiply before you divide, and you always add before you subtract. And that's totally wrong. Totally, totally wrong. I'll show you an example of that. Say, for example, we have something like 24 divided by 6 times 4. Well, if you follow, please excuse my dear Aunt Sally, in this problem, 24 divided by 6 times 4, you're going to say, oh, M comes before D, so I got to do this first. So that's going to be 24 divided by 24, because that's what 6 times 4 is. And 24 divided by itself is 1. So, oh, I got 1, that's the correct answer. That's wrong, it's incorrect. The way that the order of operations is supposed to state is that you multiply and or divide from left to right, whatever comes first. So in this problem, we have all of this class of multiplication and division. So they go together in one section. It just happens that division is first, so that's what we're going to do. 24 divided by 6 is 4, and then 4 times 4 is 16. 16 is the correct answer, not 1. So you have to think of as multiplying, dividing in one section, and adding and subtracting. So with those rules, you multiply and or divide left to right, whatever occurs first. And then after all multiplications and divisions are done, you add or subtract from left to right, whichever comes first. Now, a lot of students will say, well, Mr. Pashar, why do I give a crap about this? I'll just plug in my calculator. Well, sometimes you get very tedious computations, and if you're going to try to jam everything in your calculator, you're going to mess it up. So make sure you can at least set these things up by hand and then use the calculator to help you a little bit later. My other gripe with this is the P. P stands for parentheses, but there's more than just parentheses. We have what we call grouping symbols. So not only do we have parentheses, we have brackets, we have braces, we have fraction bars, which means you do the stuff on top, stuff on bottom, then divide lastly. Square roots and nth roots. We have something called a vinculum, which is an old-time thing, but a vinculum was just a bar on top of a bunch of operations to show the reader that's what we want to do. And we have absolute value. Absolute value is also a grouping symbol. We want to do the things inside the absolute value first. So that's kind of my gripe. So this would be more of our updated order of operations, but one being take care of all grouping symbols first, take care of exponents, which, by the way, the weird thing about exponents is sometimes you can do them out of order. Then you multiply and divide from left to right, whatever occurs first, and then you add or subtract from left to right, whichever comes first. So look at a couple examples here on how we can make the order of operations work. I gave you some examples in your lecture notes. We'll do a couple of other ones, and then I had a request for a problem or two from the textbook. So let's look at a problem like this we want to simplify. Say we have -2 plus 3 minus 4 plus 6, and well, let's do that. We'll do that first. So we have -2 plus 3 minus parentheses 4 plus 6. So first what we want to do is go through that list. Is there any grouping symbols? And there is, the 4 plus 6. So that needs to be done first. 4 plus 6 is 10. So I have -2 plus 3 minus this 10. Okay? Now, no more grouping symbols. There's no exponents. There's no multiplications or divisions, but we have addings and subtractings. So when that's the case, we work from left to right. So -2 plus 3 is 1. So we have 1 minus 10, and 1 minus 10 is -9. Notice I have no equal signs here, and the work is very uniform. It's like an upside down triangle. We're getting smaller as we go down the base here. But that's how you kind of want to think of how this works, step by step. Let's look at another one. How about something like, let's see, 4 bracket, -7 plus parenthesis 2 plus 3 minus 4, close parenthesis, close the bracket, and we'll square it like this. Okay. So now we have not only parentheses but a bracket. So we got to do what's in the bracket first. And within the bracket, you have parentheses. So this is where we're going to actually go right from the beginning. Notice this 4 is kind of glued to this bracket, which means that we're going to go ahead and multiply that 4 eventually, but not right now. So we have 4 bracket, -7 plus. Now what's going on in the parenthesis? We have 2 plus 3 minus 4. So we can just go and do that from left to right. 5 minus 4 is 1, and this whole thing is squared. So now we have 4 times -7 plus 1 is -6, and it's squared. So now what happens here? We have multiplication and an exponent. The exponent comes first. So what we're going to do is this -6 squared. And -6 squared is a positive 36. So we have 4 times positive 36. How much is that? Let's figure out. 36 times 4. 6 times 4 is 24. Carry the 2. 4 times 3 is 12. And 2 more is 14. So we get 144. You see again how uniform the work was all the way down here. Okay? So this is another example. We kind of step up a level here. This is, by the way, this is a good place to pause the video if you want to go back and see if you can do these too. I'll do a couple more examples with you here next. Let's look at something that has a fraction for the next example. How about absolute value of -10 plus 5 minus 2 over, let's see, 8 plus -6. So now we have introduced a fraction bar. So the way this works is we take care of what's on top, take care of what's on the bottom, and then we go ahead and lastly divide if we can. Because sometimes you might get a weird decimal, so it's better just to leave it as a fraction. So we have -10 plus 5, that's going to be -5 within the absolute value, minus 2. And on the bottom we can take care of this. 8 plus -6, that's going to be positive 2. What is the absolute value of -5, you may ask? That is 5. So So 5 minus 2 over 2, and that's going to be 3 over 2. So the answer here is going to be 3/2, or you can write that as 1.5 or 1.5. They all mean the same thing, all the same representation. But you see how we did that? We took care of the top, took care of the bottom. How about something like this? We have -4, a brace, -2 plus bracket, -7 plus 6 squared, plus 2, we'll close the brace, and on the bottom we have 8 minus 8. Now you may look at something like this and go, holy cow, there's a lot going on here. And indeed in the top there is. But if you have a keen sense here, take a look at the bottom first. Because what do you notice? What is 8 minus 8? Well, it's 0. Look what you have on the top. Whatever the mess is, right, because that's a lot of mess, divided by 0. Does it matter what's on the top? God, no. It does not matter, because you cannot divide by 0. So this thing is what we call undefined. You cannot divide by 0 in the real number system, even though some people would love to. This is undefined. And you may see a couple exercises like this in your homework where you cannot divide by 0. So your answer is undefined. You cannot say it's 0, right? Whatever this is on the top is not going to be 0. And by the way, sometimes you get a weird thing called 0 over 0. That's called indeterminate. And in calculus, we kind of talk about that. But always be aware of your surroundings at a problem. You saved yourself a lot of work here by looking at the bottom and saying, yeah, my Lord, look, 8 minus 8 is 0. I can't go ahead and do anything else. So this answer would be undefined. To wrap up this lecture, I'm going to look at a problem or two from the textbook that was requested from one of the students. So we'll go ahead and take a look at that. So we're going to look at a problem like number 30. Let's look at number 36. 36 says 3 times -4 plus -5 times -2 divided by 2 cubed minus 2 plus -6. Okay, so once again we have a fraction bar. This is a good example. Let's see what happens on the top. You have multiplications and an addition. So we got to go after the multiplications first. So 3 times -4 is -12 plus -5 times -2 is a positive 10. Now down on the bottom, you have a 2 cubed minus 2 plus a -6. So this is the realm of an exponent and then addings and subtractings. 2 cubed is 8. And -2 plus a -6 is -8. So you may see this already. The bottom is 0. The top is -2. -2 divided by 0. Please don't tell me -2. You should be telling me that this is undefined. Once again, you have the situation where you're dividing by 0. You can't do that, so the answer is undefined. Oftentimes students will say, they think they got something wrong and they got to that stage and they get a 0 on the bottom. But it doesn't have to be the case. You could be totally right. Now maybe if you get 20 problems in a row with a 0 on the bottom, maybe you did something wrong. However, it does pop up. Now let's look at one more problem. Let's look at number, let's say, how about we do 41? 41 is a good problem. 41 is negative 6 plus 3 times a negative 4 divided by negative 5 minus 1 minus negative 9 plus 6 times a negative 3 divided by negative 4 plus 3. So this is a nice involved problem because you have the subtraction of two fractions here. And who knows, you might have to find a common denominator, but if you have your calculator, I'm sure you'll be able to skip right over that. But let's handle this as we see it. Take care of the fraction on top, that part. So you have negative 6 plus 3, that's going to be a negative 3. Negative 3 times negative 4 is positive 12. And on the bottom, that's negative 6 because negative 5 minus 1. Take away. Over here, you have negative 9 plus 6, that's negative 3. Negative 3 times negative 3 is a positive 9. And on the bottom, you have negative 4 plus 3, which is negative 1. So you have 12 over negative 6 minus 9 over negative 1. Now, we could simplify both of these. 12 over negative 6 is negative 2. And then we have minus 9 over negative 1 is negative 9. So we have that situation there. Negative 2 minus a negative 9. So this means negative 2 plus 9, and negative 2 plus 9 would be a positive 7. So that's how that one works out there. So it looks really ugly in the beginning, but it actually turns out to be very nice in the end. With that being said, I think that's enough examples to help you get through your homework. This covers everything from chapter 6, section 2, plus you have the previous videos on part 1 of this, and then section 6.1. I hope this video finds everybody well. I hope that you are enjoying these videos. I know it's not like going to the casino or a concert or something fun like that, but I hope these videos do help you out with your work. And again, I'll be keeping this going all the way through the end of the semester till the very end. Hang in there. We're almost there. We only have a little bit to go in the course, about 4 weeks. Everybody can make it. We're all doing a good job. I have to say that I'm very happy with all the work I've been getting. That second exam, you guys did a nice job on. Just keep at this, okay? Again, if you have any questions, feel free to call or email. And enjoy the rest of your day. It's a nice sunny day out. Get out and do something. Just keep 6 feet apart, I guess, right? So until next time, be safe, take it easy, enjoy, and I'll see you when I see you.